Hello everyone and welcome back. From our previous video, we started working with DBSQL and SQL warehouses. Now, before we start working with AI/BI dashboard, I want to show you two important topics that are streaming table in DBSQL and materialized view in DBSQL. Now, if you are following this playlist, you might know that we have created streaming tables and materialized view in our DLT videos. Today, we are going to create both of them in DBSQL. Now, it is important to note that still this streaming table and materialized view which are created in DBSQL utilizes DLT as backend, and we are going to explore that as well. Now, before we can start with this video, if you have not seen our previous video or not subscribed to this channel, go ahead and watch those videos first and go ahead and click the subscribe button now. So, without any further delay, let's begin. Now, before I can go ahead and write the code for streaming table, it is important to know where the documentation is. So this is the page where you can find the documentation for streaming tables. Now, streaming tables are same as that of DLT streaming tables. This provides you support for streaming data and incremental data. Similarly, you can go ahead and find the documentation for materialized view in this page. I'm going to tag both of the pages in the description of the video. You can go ahead and check that out. Now, for materialized view, we already know it stores the pre-computed results based on the logic that you had provided from the source. So it drastically reduces your query time. But you have to refresh the materialized view whenever there is a change in data in your source, right? So let's go ahead and get started with our demo. Great, I'm back in my Databricks workspace. Now, I'm going to use Notebook today. You can go ahead and use SQL editor as well. But the important point is we need to use a SQL warehouse here. So we have already created our SQL warehouse in our previous video. So I'm just going to connect that in this particular notebook. Now, once you connect a SQL warehouse here, you can only go ahead and run SQL queries. So you can see I have selected SQL by default. Okay, so I'm just going to connect my SQL warehouse. So I'll just click on this connect and I'm going to select the SQL warehouse that I have created in my previous video. Okay, my SQL warehouse is a serverless one. So it is already up and running and you can see it has connected to this notebook. Now, first thing that we are going to do is we are going to create a streaming table. Okay, now in order to use streaming table, I'm going to read some data from files. Okay, and we are going to make sure that we read the files incrementally. It means we are not going to read the same file again and again. Rather, we are only going to process the new and the incremental files. Okay, for that, I'm going to use a volume. So we have already created a volume under dev. So I'll just expand dev. I'll expand branch. I'll expand volumes. And under external volumes, if I expand files, you can see I already have a orders file here, which is CSV file. Okay, it contains data for some orders. And we are going to create a streaming table for orders. Okay, now let's go ahead and write the syntax for streaming table. So I'm just going to write create or refresh streaming table, and I'm going to put it in the same catalog, which is dev dot bronze, and I'm going to name it as orders st for streaming table. Okay, now the next thing we need to do is we already know that streaming tables use streaming sources and we are going to read the data from this particular volume, right? Now streaming table requires a streaming source and we are going to read files incrementally as streaming source. So for that we are going to use a method called read files. You can find the documentation for read files in this particular page. It gives you all the information about read files and all other options that are available with it. Now I'm going to show you some basic ones today. You can go ahead and read more about read files in this particular page. So in order to read data from a particular volume or any S3 location or any ABFS or ADLS location, we just need to do this. So I'm just going to write as and I'm going to write select star from. Okay, now we need a streaming source. So I'll just write stream. Okay, and I'll write read files. Okay, and within bracket I can go ahead and provide the location of the volume from where I'm going to read the file. So I'll just put an enter here, and the first thing that I'll do is I'll provide the location. So I'll just use double quotes and I'll click this arrow here. Okay, as soon as I do that, it will insert the location of that particular volume. So we are going to read the files from volumes, dev catalog, bronze schema, and external volume, and under that we have a folder called files. Okay, now the next thing is we need to provide the format. In our case, the file format is CSV. So we're just going to write as format and we are going to use an arrow key like this and I'll write CSV. Okay. Now, this allows us to read files from a particular location in format of CSV. Now, since we are using streaming tables, so we will write stream so that this behaves as a streaming source. Okay, so our streaming table is ready. Let's go ahead and run this. Great. Now you can see an output message saying the operation is successful. Okay, so let me just expand table on the left hand side. If I scroll down, you cannot see any orders table here, right? Let me just refresh this. And now let me expand dev, bronze, tables. And if I scroll down, you can see here orders st. Okay, now if I hover over, you can see it is a streaming table. Okay, so now you understand how we can go ahead and create streaming tables in DBSQL. Now, one important point to note, if I click on this performance here, you can go ahead and see the performance in the query profile. But as I said, the background of streaming tables and materialized views are DLT. So let me just go ahead and show you that. So what I'll do is I'll quickly go to query history. So you can see that on the left hand side. So let me just click on control and click on query history. Now, you know that we can use query history to see all the queries that has been triggered in a particular SQL warehouse, right? So let's just wait for it. Great. Now, if you see here, we have the query history that has been executed on our SQL warehouse, right? Now, notice here we have our create or refresh table command here, right? But right after that, you see one more command, refresh streaming table. Okay. So what is happening is once the table is created, a refresh command is fired over a DLT pipeline. And that DLT pipeline is managed automatically by Databricks. So if you see here, you can see here a particular pipeline, right? It says pipeline. So if I click on this, it will open a different tab where you can see this is a DLT pipeline where orders st is a streaming table. So now you understand the streaming table that you have written in the Databricks SQL background is still DLT. Okay, and this is how it works. So if you see the pipeline here, you see this pipeline ID here. So if you go ahead and write describe extended, you'll find this particular pipeline ID in the streaming table description. Okay, so let me just show you that. So I'll come back here, and what I'll do is I'll write describe extended. Okay, and I'll copy the name from here. And if I run this, great, you can see if I scroll down, you can see this is a streaming table. Now, if I expand the table properties here, you can see pipeline ID here, right? So you can see this is the pipeline which is used in order to manage this particular streaming table. Now, if I go back to the pipeline that we opened for DLT, you can see this is the same pipeline ID 52B, right? In the end, you can come here and you can see this is 52B. So now you understand how streaming table works in DBSQL. The background is still DLT that is being used to manage in order to refresh this particular streaming table. But the question here is we are trying to see how we can process incremental data using streaming table. Okay, so let's first see how many records are there in this once we loaded this particular orders file. So I'll just copy this and I'll run a select star here. Okay, so I'll run select star from and I'll paste the table name and I'll run it here. Great, the query execution completed, right? So if I scroll to bottom, you can see there are total 14 rows. Okay, so let's go ahead and put one more file and see how we can make it behave as an incremental way. So I'll just close this here. I'll expand the volume again. I'll expand external volume. I'll expand the files and I'll upload one more orders file here. So what I'll do is I'll quickly click on this here. I'll click to upload button and I have added one more file called orders2. Okay, I'll just click on upload. Great, the file is uploaded. So I'll just close this pop-up here. I'll expand on the left hand side. Great, now you can see orders2 file here as well, right? But now even if I run this command again, it will again load the same file because right now it is not behaving as incremental. In order to make sure it behaves as incremental, for read files, we need to add one more property, that is include existing file as false. Okay, by default that is true. It means if I rerun this, it is going to read the same files again. Okay, we have to make sure it only reads the new file. So what I'll do is I'll just add one more property. I'll write include existing file. Okay, let's find it in the documentation. So I'll just go to read files. I'll find it here. You can see it is include existing files and it is set to false. So I'll just copy this from here. I'll go back and I'll paste it here. So it will make sure that we are not reading the existing files again. Okay, so let's go ahead and rerun this. Right, the operation completed. It says the operation was successful. So let me just go ahead and run the select command again. So I'll come back to the select command and I'll rerun this. So it has just completed. So if I scroll down now, you can see more than 14 records, right? So if I scroll down, you can see approximately 38 records. It means we have successfully loaded the second file, which was orders 2. Okay, so now you know how you can go ahead and read incremental files using read files. Okay, and you have to add one particular option, which is include existing files as false. Okay, so this is how you can go ahead and create streaming table. Now the important part. So in streaming table, you can go ahead and refresh the table again and again in order to read files. So what you need to do is, in order to refresh a particular table, you can just refresh streaming table and you can paste the table here. Okay, so if I run this, it is going to refresh the table. So if you remember in DLT, if you want to refresh a particular table, you can go ahead and do it like this. But if you want to completely erase and reload the complete data, you just need to put full. Okay, so this is just like full refresh in DLT. So if I remove this and if I run this, it is going to refresh. Okay, so right now, since we have already loaded both the files, there will be no refresh, so there will be no new data loaded. So let me just run this again. So it is complete. So if I scroll down, so previously there were around 38 records, right? So let me just rerun this select statement again. So it just completed less than 1 second and you can see it is still 38. Okay, now again, backend is still DLT. Once you run this refresh command, it is going to run it in DLT. Okay, so you can go to query history, you can refresh here. Okay, and you can see this particular refresh has run in a DLT pipeline. You can see the DLT pipeline here. Okay, and everything is serverless, so it is all running on the back end in serverless. Okay, so let me just go back, and this is how you can refresh a streaming table. Okay, now that we have seen how we can create streaming tables, let's go ahead and see how we can create materialized view. Great. Now we know that materialized views are used to save pre-computed results. Okay. So what we are going to do is we are going to create a materialized view based on some conditions and aggregation based on this streaming table. Okay. So you can see this is our streaming table. We are going to write our materialized view based on this particular streaming table. We are going to aggregate data based on order status and we are going to put a sum on total price. So let me just scroll down and we are going to write our first materialized view. So to do that, I'll just write create or replace and we'll write materialized view and I'm going to put the name as MV. Okay, so MV is for materialized view and I'll write as, and now I'll put the condition. So what I'll do is I'll write select and I'll write from and I'll put the table name here. Now I'm going to select the column which is O underscore order status and we are going to aggregate O underscore order price. Okay, so let me just go ahead and check the column again, total price. Okay, let me just change that, so it would be total price. Okay, and I'm just going to rename this as AGG total price. Okay, and let me just put a group by here. So what I'll do is I'll just write group by and I'll paste it here. Okay, so now if you understand, we are going to create a materialized view here and this is going to save this pre-computed result. So every time you refresh the materialized view, it is going to check the below query and it is going to refresh the data here. So whenever you query a materialized view, it would not go ahead and run this query on the source table to see it. Rather, it will bring in the pre-computed result. So that will drastically reduce your query time. So let's go ahead and create this materialized view. So I'll just run this now. Great, our operation just completed. It says the operation was executed successfully. Okay, now you can see our materialized view is created. So let me just expand on the left hand side. This is dev bronze and I'll refresh the tables again. So let me just refresh this and I'll expand on the left hand side, which is dev bronze, and I'll expand the tables. If I scroll down, you can see orders MB, which is the materialized view. So now that our materialized view is created, let me just query this. So I'll just write select star from. Okay, and I'll copy the name from here and I'll paste it here. Okay, so let me just run this. Great, now you can see the result here. This is the value for O and this is the value for F. Let's go ahead and add one more orders file for the streaming table and then see the orders value changing for materialized view. So what I'll do is I'll quickly go to the volumes here. I'll expand the external volume, the file, and I'm going to add one more orders file here. So what I'll do is I'll just click on this. I'll click on upload to volume and I added orders 3 file. I'll just click on upload. Great, the file is uploaded. Now let me just expand on the left hand side. So I'll expand dev bronze volumes, external volumes, files. Okay, you can see the files here. Now even you can list the files using SQL command as well. So you can go ahead and use list command. Okay, and you can provide the location like this. So I'll just click on this. So this will give you the volume location. Let me just run this, and you can see all the files here. Okay, so you can also use list command in DBSQL in order to list all the files under a volume or S3 location or ABFS or ADLS locations. Okay, so now that we have uploaded the file here, let me just go ahead and refresh our streaming table first. So what I'll do is I'll just copy this here. I'll click on code. I'll just write refresh streaming table and I'll paste, and I'll just change the name to ST, and I'll run this. So in the background, this will run a DLT pipeline in order to refresh the data. So we'll just wait for it. Great, our streaming table was refreshed. So let's go ahead and refresh our materialized view now. So what I'll do is I'll just copy the name again. And what I'll do is I'll just click on code and I'll write refresh materialized view, and I'll paste the name. Okay, so let me just run this again. Great, our materialized view was also refreshed. So let me just go ahead and run the select command on the materialized view again. So you can see the values here, right? So I'll just copy this and I'll run in a different cell. So I'll just click on code, I'll paste it here and I'll run this. Great, it completed. So let me just scroll up a bit, and now you can see the difference here. Okay, you can see this is the value for O now, this was the value previously, and again for F the values have changed. Okay, so the new data was inserted into the streaming table. Similarly, the new data was updated accordingly for the materialized view. Okay, so now let's quickly go back to our query history once more. So I'll just go to query history and let me just refresh this. Great. Here you can see the refresh that we have just run. Okay, so this is the refresh materialized view orders MB. Okay, so if I click on this DLT pipeline here, great, you can see the pipeline which has just refreshed the materialized view. So if I scroll down a bit, you can see here the orders MB has been planned as group aggregate. So if I click on this, if I go to JSON here, if I scroll down, you can see this particular aggregation has ran as group aggregate. So it has not done a complete recompute. You can see this is complete recompute. It means it has not read all the data from the streaming table, rather only read the incremental data and processed the aggregation incrementally. Okay, so that is one more benefit of using Materialized View. It is not going to read the complete data from the source side, rather it is going to read incremental data, perform incremental aggregations. And you can see here, this has been chosen, this has not been chosen. You can see this chosen false. Okay, so you can see here, this is complete recompute, which is false, and group aggregate is true. So this is one of the incremental strategy that Materialized View uses. Now, let me show you one more thing. So what I'll do is I'll quickly go back and I'll rerun this refresh. So I'll quickly just go down here and I'll rerun this refresh for this materialized view. Okay, so I'll just run this again. Great, you can see it has completed. Let's quickly go back to query history again. Let me refresh this page. Great, you can see here the refresh materialized view command. You can see this orders MB. Let me just go ahead and click on this. Great, now it has opened the materialized view along with the orders MB. So let me just scroll up. And now if you see the planning operation, it says no op. So if I click on this, if I expand the JSON, you can see it has used no op now. No op means no operation has been done because there was no incremental data to process. So it has automatically judged that there was no incremental data to process. So no refresh was required. So it has performed a no op here. Okay, rather than recomputing the complete logic, it has completely ignored because it knows that there is no incremental data to process. And that is one of the benefit of Materialized View. Okay, so it can incrementally judge and refresh your data accordingly, which can save a lot of time. And again, since the results are pre-computed, you have a lot of time to save when you query a Materialized View. Great. Now that you understand how you can go ahead and create streaming tables and Materialized View in DBSQL, let me show you one more thing. Now, you can go ahead and schedule the refresh for Materialized View. What you can do is, when you create this create or replace command, you can go ahead and rerun this command as well in order to refresh, okay? But if you want to schedule this in order to refresh automatically, for example, in 4 hours or 1 day, what you can do is you can schedule this. To do that, you can go ahead and use this syntax. So after you write create or replace Materialized View, you just need to hit enter and you need to write schedule every, for example, I'll schedule this in every 4 hours. So what I'll write, I'll 4 hour. Okay, now if I run this, it is going to make sure that my materialized view is triggered in every 4 hour and the data is refreshed in every 4 hour. Okay, same thing you can go ahead and do for streaming table. For example, if you want to refresh your streaming table in every 4 hour, same thing you have to do. Just copy this schedule. If I go up to the streaming table command, Okay, and I can paste it here. So if I run this, it is going to schedule this and it is going to run in every 4 hours in order to look for incremental data and add it in the streaming table. Okay, so today you understand how you can write streaming tables and materialized view using DBSQL, what is the backend and how it works, how you can go ahead and debug what has happened in the background, and how you can schedule those if you want to refresh them automatically after a particular tick. Now, you can also use cron syntax. For example, if you don't want to run it in every 4 hours, you can use cron syntax. You can just write cron and you can provide the syntax, whatever be your cron syntax. Okay, so I hope you have learned a lot about streaming tables and materialized view. In our next video, we are going to create our first dashboard using AI BI. Now, it takes a lot of efforts in order to create these videos. So I want you to make sure that you like and subscribe to this channel and share this with your friends. Till then, keep learning, keep growing, and keep sharing.